Python packages or modules, and how do you install them in Python? In the last video, we installed the Anaconda distribution and checked if a Python installation was correct by printing hello world. Now, what happens if you want to do more? Like, how do you, let's say, read an Excel spreadsheet? Or how do you, let's say, build a pie chart with some sample data you have? Or how do you download data from NSE, the National Stock Exchange of India? So Python strives on open source. There are tons and tons of contributors which write good code and put it up on GitHub for everyone to access it publicly. So uh, they are called as packages. Now, how do you import these packages? Before we move on to how do you do it on a Python terminal, let's just see a very quick example or how a sort of a package looks like. I'll just revert to my blog, which will have this example. Let me just resize my window. Yeah. So what do you call of a package? So a package is like, a box where you have different sub packages, like you have multiple sub packages, and within those sub packages you have the things that you want to use, the functions or classes or any relevant code that you want to use. Think of it like a branch, like a bank branch, your normal State Bank of India, Bank of Baroda branch, where that whole bank is like a package. Now inside that bank you will have a department which gives out loans, a department which gives out, I mean, lets you open new accounts or just lets you deposit or withdraw money, that sort of stuff. So these are all small, small packages within that big branch. And hang on. So yeah, all these packages or branches within that, the departments within the same branch are, which they make a package basically. Now, you might ask, why do we need different modules, different these .py files here when you can just put all your code into one file and then it's just easier to manage, like just one .py file. It often happens that when you are developing code, as long as it's a small piece of code like 500 or 600 lines at a maximum, even go up to 1000 lines, it's still easy to manage and everything. But as in when you develop whole systems, whole trading systems, and things become complex, your code can easily run greater than 1000 lines, and then it gets really, really difficult to manage as to where did you write a particular function, what is this function doing, what is that function doing. Too much confusion. It's better to just keep relevant functions into different sub packages and then call those sub packages into this one big main package where you will be running your overall trading robot or any screener sort of app. So that way it's better. Like imagine, I mean, if you worked in a corporate environment, one particular boss is like managing around 1000 people. That's insane, right? One particular boss will have certain 6 7 direct reports to him, and then that person will manage these reports, and these reports will manage people below them. So that's how it's easier to manage. If that one guy had to speak to 1000 reports and do their one to ones, it's crazy. It's not possible. So similarly, it's not possible to keep all the code in one. It is possible, but it's not sensible to keep all the code in one file. It's better to split them out. Okay, so let's see what a normal package would look like. So for this, I'm basically going to GitHub, which is an like you can share all your code and everything here, and I'll open up the matplotlib library, which is the most famous library for plotting things in Python. Like if you want to build a bar chart, candlestick chart, or pie charts, or any sort of chart. I mean, there's so many charts. Uh, you can build that via matplotlib. Let me show you their official website where they have everything as to what you can build, what you cannot build, and with examples they have each and everything, like different types of charts that you can build. So all of this is now open source to you. It's available freely on GitHub. You can just install them on your laptop and start using them without paying anyone. And that's the beauty of the open source community. Everyone is selfless and trying to develop things for the betterment of everyone. So this is the matplotlib library. Now if I go to this library sort of a package. Inside the library package, there are two other packages which are matplotlib and mpl toolkit sub packages, I would say. If I go to the sub package of matplotlib, there are another set of sub packages which will have those .py files within them, which are used to call that data. So there are a couple of .py files directly under this matplotlib sub packages, but there are another set of sub packages as well where you have another set of .py files. So all of this collectively build this matplotlib package. Now the question comes in, okay, all of this is fine and it makes sense. How do I install the package that I want to install on my machine? So let me just bring that up on your screen. Sorry, give me a minute. I'm just doing something on my other screen. Okay, yeah. So basically, let's say you want to install a package. Now, there are two ways to install a package. One is the Conda method, Conda install, and then the second method is called pip install. Pip is the Python, I don't know the full form actually, let's just check. Pip is not this one. Pip full form Python. Pip install packages. Pip stands for Preferred Installer Program for Python. And then the other method is Conda install, which is so I'll tell you briefly what the difference between pip install and conda install is. Whenever you are installing a package, if you do a pip install, it will just plainly install the package, and as you know, some packages will have been built on top of other open source packages, so it will install all of them in one go. Whereas what conda will do is conda will check, okay, I want to install this package. What are these existing packages that I already have which I do not need to install? So let's say if I want to install matplotlib, now matplotlib might have a dependency on pandas, which is another package. Now if pandas is already installed in my laptop and it is the matching version which matplotlib wants to function, Conda will already do all that work for us and will not reinstall it again. If let's say Panda's version is 1.12 and Matplotlib requires 1.13, Conda will, when we install Conda install Matplotlib, it will basically check that, oh, my Panda's installation version is incorrect, or it's down, it's one down below what I need. So it will directly upgrade that existing Panda's version so that Python doesn't, sorry, Matplotlib works properly. But let's say if you want to install Matplotlib again, and that has a dependency on, let's say, NumPy, which is another library for dealing with arrays. Now, there is another package in your system which says, okay, NumPy version should be 1.25, and Matplotlib says it should be 1.26. But because that other version, you cannot, upgrade it to 1.26, then Conda would do all of that work for you. Conda would check, okay, can Matplotlib survive on 1.25? If it cannot, then just show an error to the user. If it can, great. Just stick to 1.25 because there is another package which requires that 1.25, and then just install it. So pip will just install the package for you regardless of whatever you have, what you don't have, and just do what it's told. Conda, on the other hand, would check everything in your system, check nothing is breaking in the overall picture, and then just install that package, or either upgrade it, downgrade it, whatever it needs to. So let's now try and install matplotlib. So the way you, I mean, the preferred version is always conda, but there are some libraries which might not be available on conda. So then it just makes sense to install them via pip. So if I want to install matplotlib, I'll just go conda install matplotlib. Now, if I want to do a specific version, then I do is equals to and then mention that version. I don't care about the version here, so I'll just do conda install matplotlib, press enter. Now it will say basically that it's solving environment. Now this solving environment part is where it checks that, can I install matplotlib without breaking something, and now it just tells me, okay, the following new packages will be installed. So matplotlib depends on all these packages right now. It has a dependency on all these, so I'll just do y and then enter, and then it will just start installing everything. Now, let's install another package which is called the Jupyter Notebook. Now, Jupyter Notebook is one of the most famous integrated development environment out there, where beginners find it really, really useful to write code because it's like cell by cell based execution, which I'll show you right now. But yeah, I mean, you can do a lot of things, and it's very easier to debug your code. So let's just install Jupyter Notebook. So conda install Jupyter Notebook. Like I personally use whenever I'm starting a new project, I would personally use Jupyter Notebook first to see how the code is working, how can I make changes to it, how can I build whole function to it, and then move on to, let's say, VS Code or any another editor. Oh, in my case, the Jupyter Notebook is already installed, but if you're running this for the first time, it will do the same thing again, solving environment and then show you a package plan. If you just press enter Y and then enter, it should be fine. So if I want to launch a Jupyter Notebook now after I've installed it, just type in Jupyter Notebook in there, and then press enter. This should open up on your default browser, be it Edge or Chrome or anything, and where you can just create a new Jupyter Notebook file. So I'll go to. Hey, sorry guys, I had to cut off the video there because there was just too much sun coming to my face and I was feeling really hot, but I've now put up the curtains. So we were at the Jupyter Notebook and I was just going to go into desktop and let's say Python files and just going to the folder where I want to create a new file. So I'll just create a new file by clicking new and then Python 3, which should open up a new tab for me. And once this tab is open, you can rename it by clicking on untilted. So I'll say package YT YouTube for me and rename it. And now let's just test if we have installed the matplotlib library correctly or not. So import matplotlib lib.pyplot. So that's, I mean, that's another sub package within matplotlib which generally has all our plotting functions. So import matplotlib.pyplot as I'll just import it as PLT because you don't want to write matplotlib.pyplot all the time. So just import it as PLT. So you can use that shortcut wherever you are mentioning this matplotlib.pyplot in your code. So, and that's it. If that works without any error, then our installation was successful. If that shows up an error, then there's a problem. To give you some context, let's just, import, I don't know, some random library like, let's say, the maybe Telegram send. This is a library. So import Telegram send. Oh, that worked because I have this in this environment as well. Let's try something else. So import Seaborn, which is also another plotting library. Import Seaborn as SNS. Now it will say no module named Seaborn. Now if I quickly install Seaborn uh, into my with Conda, that should work. Let me just Conda activate YouTube videos. Conda installs Seaborn. So now it gives me a package plan. I'll just do Y and then it will start installing that package. Okay, so the package installation was complete. Now if I try to do this again, import Seaborn as SNS. By the way, to run this, you do Shift and Enter. And this is what I was talking about. This is called the Jupyter Notebook environment where you can like run each and every cell at like one time rather than running the whole script, which gets difficult to figure out where an error is. And this gives you the view that, okay, this cell is exactly doing this purpose. So, okay, so now it worked. We did not have any error like no module installed. Let's quickly try a matplotlib example, maybe from the documentation itself. I'll just copy this, replace it with this, and just copy this whole code from here just to try if it works or not. So just rerunning everything and just copy this as well. So what this is doing is, I think so, this is mm, like five different data points for men and women, and then the standard deviations. And then it's basically just plotting those standard deviations somewhere. Okay, so now it tells me access subplot object has no attribute bar label. So maybe this documentation is kind of outdated. Like, let's just get rid of this thing and just keep plt.show. Okay, so that error goes away. And now you can see your plot. So, you were able to install a package, open it up, and, bring it in your code just by importing it. And then now you're able to plot without, developing that whole code for plotting yourself, because that is incredibly complex at the background. Now, what happens if a particular package, let's say, is not available by Conda? I know of one package, Jugaad Data, which is used to download Bhav copies from the National Stock Exchange of India, does not get installed by Conda. What happens if I, install it using Conda? Jugaad Data it is Jugaad Data, right? Let me just double check. Jugaad Data. Okay, so I put an underscore. I should have put a hyphen. So let me just, whenever you want to interrupt an existing Conda program, just do Control C, and it will tell you Conda error keyboard interrupt. And if that sometimes, just stucks up, just close this one and open up again. Don't worry about this conda activate command. This is just going into my virtual environment because I have too many of them. We'll talk about virtual environments in the next video. So let's just try and install Jugaad Data. So Jugaad Data lets you download Bhav copies for whatever date you supply. It also lets you fetch live prices. We'll do a video on this one, but out of the scope of this video. So it tried, and then it says packages not found error. The following packages are not available from the current channels, blah blah blah. So then our only option is just to do pip install Jugaad, oops, data. And that should work. And pip generally is much more faster than Conda because it does not have to, look for any of the packages or dependencies within our existing environment. It will just go and install it. And now you can see it got installed. In my particular environment, it was already installed, so it just says requirement already satisfied. So I guess that gave you a good view about what are packages and modules. Within a package, there can be multiple sub packages and then multiple modules. And again, it is very, very good to have your code written into different sorts of modules and not just use one .py files. Just because if things go wrong, then it's easier to point that out, and it's easier for other people when you're sharing your code. It's easier for them to read and understand what's happening, what's getting imported, what's, where you're using particular variables, and just, helps you with debugging as well. So, yeah, that's it for this video, guys. Thank you so much for watching. Next video, we'll talk about virtual environments. Have a good day.